This video is called the Pythagorean Theorem. This is probably one of the more famous of all mathematical truths with a capital T. And the neat thing about mathematics is that things were true thousands of years ago still are true today. And this is one kind of neat example of the Pythagorean Theorem. So the Pythagorean theorem works for right triangles. And so if that side is called A and that side is called B and the hypotenuse is called C, what the Pythagorean theorem states is the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse Okay, now notice that we're talking about a right triangle, and this only works for right triangles. But another way to say that, of course, is that a squared, this length, plus b squared, the other leg squared, equals c squared, the hypotenuse squared. And of course, remember that c, the hypotenuse, is across from the 90-degree angle. So c has to be here by itself on an island, and a squared and b squared are on the other side. Okay, that's a Pythagorean theorem. This theorem has a geometric interpretation, and here's a neat website which kind of illustrates that idea. So this is brought to you by PBS and the nice folks at Nova. But what the Pythagorean theorem says is that the square off one side of a right triangle plus the square off another leg of a right triangle, if you add those two areas together, it's going to be the same as a square built off the hypotenuse of that right triangle. And so basically it says you take this area, this green area, and that blue area, and it's going to be equal to this white area. And so that's a geometric interpretation. So this is kind of a neat little applet that allows us to play around with this. So I'm going to bonk this over here. Okay, there's my a squared, and I'm going to try to fit b squared over there, and it doesn't really work out. But I can break each piece of the b squared apart and rearrange them. And so what I'm doing is I'm placing the whole a squared plus the whole b squared to be equal to the whole c squared. And again, you can kind of move this around and play with it on your own if you so choose. There are a lot of different ways to do that. A neat part about the Pythagorean theorem, it's been proved so many times, including by President Garfield. And in fact, I've seen a book with over 400 proofs of the Pythagorean theorem. But this is one interpretation. It's not a proof, it's just a little demonstration for this particular case. So what does the actual proof look like for the Pythagorean theorem? Well, here's what we're going to do to prove it, and perhaps this is of interest to you, or not. Either way, here we go. So let's prove it. And this is kind of a nifty little slick proof, and it's brought to you, we're going to use AH, altitude on hypotenuse. So what I'm going to do is I'm going to try to prove that for any right triangle. Let's start with a right triangle. A squared plus b squared equals the hypotenuse squared. But what I'm going to do is I'm going to bonk that hypotenuse, the altitude on the hypotenuse. And since the whole hypotenuse was c, I'm going to call that piece x, and therefore the remaining piece is c minus x. Okay. Now I'm just going to use the AH rule, right? And one of the AH rules is that the leg squared, this leg, is equal to the product of the piece that hits that times the whole hypotenuse. Leg squared, here's your leg squared equals piece times whole. Okay, that's one outcome of AH. I'm going to do the same thing for b squared, another leg squared, and that's equal to the product of the piece that hits it times the whole again. So again, to visualize that, b squared is equal to the product of that piece times that whole c, hypotenuse. Okay. Now what I'm going to do here is I'm just going to add these two together. And on the left I get a squared plus b squared. And on the right I get c times x, xc, and times c times a quantity, c minus x. Right, that's the addition property of quality. I'm going to clean that up a little bit. And a squared plus b squared is still here. And what do you think we get on the right? Well, I'm going to distribute that c to get c squared minus c times x. And lo and behold, x times c minus c times x is 0. So of course we end up with the Pythagorean theorem. And that's a little slick proof of the Pythagorean theorem, one of the slicker ones I've seen. So that said, this is the Pythagorean theorem. I showed you both the proof that uses AH. That's what the Pythagorean theorem says. And of course, there's a nice geometric interpretation. We're talking about squares that are made off the sides of a right triangle. And it has to be a right triangle, well, at least based on this proof, because if that ain't a right triangle, we don't have three similar triangles, and we can't set up those proportions and multiply them through, which give us altitude and hypotenuse, which give us these particular rules for right triangles. Okay, so I hope you enjoyed it. That's one proof of the Pythagorean theorem. We're going to use it tomorrow. Don't forget the geometric interpretation. That whole a squared plus b squared, when you break it up, fits exactly into the area off the hypotenuse for any and all right triangles. Have a great day. Bye-bye. We'll use this tomorrow in class.